As mentioned in our conversation, I must emphasize again that the outcome of your research has yielded truly extraordinary results. I do not presume to question your procedures, but in the name of science and for the good of humanity, I will allow myself to analyze your findings, since my hypothesis is that your result is significantly overestimated and all the input data is unknown to me. I will have to use an above-average size ceiling as input. In this case, it will be a truly extraordinary piece of ceiling measuring 10 by 10 meters and 1 meter thick.
Damn, boy! Damn, boy! He's thick! Boy! That's a thick-ass boy!
As a next step, I will define the composition of the ceiling. I will base myself on the average values for 1 cubic meter of reinforced concrete used for the construction of block buildings. In this case, it will be a concrete mix consisting of 400 kilograms of cement made up of calcium silicate hydrate, calcium hydroxide and ettringite in a ratio of 6:2:2. Further sand and gravel weighing 1800 kilograms consisting of silica and calcium carbonate in a ratio of 80:20. The mixture also includes 200 kilograms of water.
Hello, how are you? I am under the water. Please help me. Here too much raining.
And the last, very important part, reinforcement steel rebar. Steel consists of 99% iron and 1% carbon together with a weight of 150 kilograms. As a next step, we will determine the number of atoms in individual molecules of the compounds and their molar masses. Now we can continue the calculation by finding the weight of 1 mole of each molecule. Once we have the molar masses of the individual compounds, we can calculate how many moles of a given substance are in the total mixture of 1 cubic meter of reinforced concrete. Since our research does not focus on calculating the number of molecules in the ceiling, but on the number of individual atoms after multiplying by Avogadro's constant, we must not forget to multiply the values by the given number of atoms in the individual particles. Once we complete this step, we have no choice but to count the individual quantities, what leave us with result of 936 times 10 to the power of 30. Now let's compare our results. I tried to interpret your results using online factorial calculation tools, but they were extremely disappointing. Most of them did not support numbers larger than 1 million, and the rest simply wrote that your result is equal to infinity. However, without mathematical proof, we cannot compare our results. For this reason, I was forced to program my own algorithm for calculating factorials. After finishing the program, I put your output data into it and ran it. After 2 hours of running the program, my laptop was almost dead. But the calculation was still far from finished. However, thanks to the properties of the factorial, even if the program has not run completely, the results of lower factorials still appear as a byproduct. Therefore, I decided to stop the program at the factorial of the number 400,000, since this number alone is enough as mathematical evidence to refute the correctness of your calculation. So what are the conclusions of my analysis? Let's take a look. The factorial of the number 4 million is many times smaller than the factorial of the number 8262627, but even so, its size is absurd. The text file containing this single number is 25 megabytes in size. After I copied it into Word, I found that it had seized up more than 6,000 fucking pages. After further analysis, I found that it is more than 20 million digits long. I dare say that it is more than obvious that the result 9 times 10 to the 30th is significantly smaller than 10 to the 20 million. The disparity is so huge that I have to describe your research as a mockery of the scientific community and I don't understand how you could think that you could get away with something like this.
My disappointment is immeasurable, and my day is ruined.